Hi, this is Lisa. In this video, I'm going to talk about functional notation and what a function is. So to start off, we've got four definitions here. A relation is a set of ordered pairs. A function is a special type of relation in which no x values are repeated. And that's primarily what we're going to be using in this course, and we'll give you some examples of relations and functions below. The domain of a function or a relation is the set of all x values, and the range is the set of all y values. Domain is sometimes also referred to as the input values. What are you plugging into the function? And the range is often referred to as the output. And we can use any variables that we choose for input or output, but x and y are the most common of those. In the first example, we're going to determine if the relation is a function, then we're going to give the domain and range. So in this example, if we look at all of the x values, we see that all of the x values are unique. Okay, a function says a relation in which no x values are repeated. There are no x values that correspond with two different y values, so this indeed is a function. Our domain, we use the set braces here because it's a set of specific numbers. Our domain, or the x values, are -3, 0, 1, 3, and 5. That's the set that makes up our domain. The range, and I'm going to change colors here, I'm going to write in black for the range. The range are the set of all the y values. So if I circle these numbers, these are all the numbers that are in my range. And oftentimes we're told to put them in numeric order. So we want to go from the smallest or most negative up to the biggest numbers. So it's kind of easy if you circle them first. The smallest number we have is -2. And then -1. It's repeated. You only write it once, and it's okay to repeat the y values, just not the x values. We have 7 and 9, and that set makes up our range. I'm going to look at a couple more examples. Example number 2 gives us a chart with values in it. Okay, is this a function, yes or no? Well, if I look here, all of my x values are the same. X equals 3 corresponds with multiple different y values, so in this example, no, it's not a function. Our domain, again, is the set of all x values. In this example, we only have 1, so we're just going to put one number in our set braces to determine the domain. And next, when we go to find our range, remember, range are y values. So we have the set, and if I put them in numeric order again, -7, 1, 5, and 7, they go in the same order that you see numbers on the number line from left to right. Example number 3. Now I'm going to draw the arrows as they're shown in your book. 1 corresponds with 5. 2 corresponds with -2. 5 corresponds with -2. Remember, we can repeat y values. So up until this point, each x value is corresponding with just one y value. It's still a function. But if we look at 11, 11 corresponds with 5 and 11. This makes it not a function because the x value 11 is used twice. It's used to correspond with 5 and it's used to correspond with 11. We can still talk about our domain and range. Domain, the x values, -1, 2, 5, and 11. And remember, those are in numeric order from left to right. And our range again are the y values. We're going from -2, 0, 5, and 11. We're not using interval notation here because we don't have all the numbers between -2 and 11. We only have those 4 numbers that make up our range. Example number 4. Again, this gives us a set of points. If I look at all of my x values, 1, 2, 3, 4, 5. None of them are repeated, so yes, this is a function. And my domain, 1, 2, 3, 4, 5. My range, the set of all y values, when I look at this, my range is repeated. Okay, I have just one number in my range, just one y value that's being used. So that's what we're looking at when we talk about domain and range and whether or not a set of points is a function. This is the end of the video on functions.